everyone. So today we will start with a new lab. So today we will learn that how we can generate the Anaglyph, that is a 3D surface model with the help of Cartosat-1 data. This exercise we will do on the ENVI. ENVI is a GIS software, and with the help of ENVI and Cartosat data we can generate the Anaglyph and DEM of the Cartosat-1 data, that is a spatial resolution of 2.5 meter. As I already discussed that this data we can purchase from the NRSC. So you can get the data from NRSC and you can generate the high resolution DEM with the help of this data on the GIS software. So before going to the generation of the DEM and Anaglyph, I will explain you that what is the difference between the DEM, DSM and DTM. So DEM, as I already discussed, that is a digital elevation model and that acquire elevation data only from the bare earth surface, and that remove all the elevation which are coming from the natural as well as the artificial artifacts. And DSM is a digital surface model, that means the elevation is only coming from the elevation is coming from the bare earth as well as the artificials and natural features. That means the elevations is also included from the trees or houses or buildings. So any kind of natural structures or natural as well as the artificial structure which are the present on the earth surface. So all the elevation data is included on the digital surface model. And another model is the digital terrain model. It is also a DEM, but when you are processing your DSM or DEM, which is included the natural as well as the artificial elevations data, if you are removing this data from your DSM or DEM, then that is called your DTM. So here you can see this is a DEM and this is a SRTM DEM of 30 meter resolution. So this although this is a SRTM DEM, but here you can see over this area these are all the elevation which are coming from the due to the vegetations. So this is a kind of DSM, but when you are removing this this error from the DSM or the elevation from this elevation which is coming from this vegetation, so that will be your DTM, digital terrain model. So here there is another example of DEM. So this is the DEM of SRTM data, but in the 3 dimension. Here you can see the elevation is only coming from the bare earth. Here the another example of DEM. So you can also generate DEM with the help of real time kinematics. So the RTK, and this is an instrument which is with the help of the GPS, the rover and base antenna, you can acquire the elevation data from the earth surface, and you can process those elevation data on the GIS platform, and you can generate the DEM. So here you can see this is a high resolution DEM of which is prepared with the help of RTK. Here the another example of DSM, you can see this is a DSM which has been acquired with the help of UAV, and this is also a high resolution DSM. And here you can see these are all the houses, and these are all houses, and these are all vegetations. So the elevation data which are included on this DSM is coming from the bare earth as well as the houses as well and the trees. So this is called the DSM. Here the another example of DSM, and this is in 3 dimension. Here also you can see these are the houses and these are all the small trees. So the elevation which is included on this DSM is coming from the bare earth as well as the from the natural and artificial artifacts. So these are the some common difference between the DEM, DSM and DTM. So now we will move forward to the Cartosat-1 data. So as I already discussed that Cartosat-1 mission was launched by ISRO in May 2005, and this is a this satellite is acquiring the stereo pair data. It includes the 2 cameras with the panchromatic sensor, and in a which acquiring the data in visual range, and this 2 camera is the forward and another is the afterward camera. So this is a high resolution Cartosat data which has been launched by the ISRO in May 2005, and it includes the 2 panchromatic camera, and the each pixel of this camera has a high spatial resolution of 2.5 meter, which is covering the data in a visible range of visible region of 500 to 850 nanometer. So the 2 band which is in the forward and afterward camera, that is the band A, the afterward image, and the another is the band F, the forward image. This band F has a off nadir angle of plus 26 degree, and the band A has a off nadir angle of minus 5 degree. So this with the help of this 2 forward and afterward camera, this satellite is acquiring a stereo pair data with a spatial resolution of 2.5 meter. So this band A, you can consider it as a left eye perspective image, and band F you can use this for the right eye perspective image. As I already mentioned that this is a stereo pair data, so you can consider your band A as a as your left eye and band F as your right eye. So with this left and right image, you can generate the stereo pair observation with the help of this band A and band F. So this Cartosat-1 data is also coming with the with the RPC, rational polynomial coefficient, because this is the orthokit data. That means it is included with the some ground control points, and with the help of this ground control point you can ortho rectify this data. So this RPC values provide true ground control point that can be used for image triangulation and ortho rectification. So this Cartosat data is available at the National Remote Sensing Center, Hyderabad, and you can purchase this data from the NRSC with a cost of per scene around 2000 Indian rupees, and you can directly order this data from the Bhunidhi portal, as I already discussed in one of our previous lab. So this Cartosat mission was launched in May 2005. So the orbit is the sun synchronous orbit, that is the polar orbit. That means your the satellite is rotating from pole to pole. So all the satellites, the earth observing satellites are acquiring data that is rotating from pole to pole. So these are all the polar satellites. So Cartosat-1 is also a kind of polar satellites. So there are 3 kind of orbits are available. So the one is polar or sun synchronous orbit, another is the equatorial orbit, that is acquiring data, or the satellite is moving from equator to equator, that means the north east to west, and the another is your geosynchronous satellite, that those satellites are basically your navigation satellites. So all the satellite which are giving you the which are using by the this navigational organizations, so those satellites are orbiting from the inclined orbit. So those satellite the orbits are called the geosynchronized orbits. So this Cartosat-1 is your sun synchronized satellite, sun synchronized orbit, and it has a orbit minute of 97 minutes. That means it complete its one orbit around the globe in 97 minutes. So number of orbit per day is 14. So in one day it complete 14 orbit around the globe, and the local time of equator crossing is 10:30 am. That means, because this is a sun synchronous satellite, so this kind of satellites having a set of angle with the sun. So that means it at 10:30 am every day this satellite will cross the equator, and the temporal resolution of this satellite is 126 days. So this satellite will acquire the data from the same region in every 126 days, and the spatial resolution of the satellite is 2.5 meter, and the SOT is 30 kilometer. SOT means the ground coverage, or the IFOV, instantaneous field of view of these satellites, is 30 kilometer. So here we have write some steps so to generate the DEM and the Anaglyph on the ENVI software. So first you have to install the ENVI software in your respective PC, and once you will open your software, you will see such type of window will open, and here you can see some options are given over here, and with the topographic module you can see there is a DEM extraction module, and this DEM extraction module is especially used for the extraction of DEM. So for that you have to use the Cartosat-1 stereo pair data, or any kind of data which is having the elevation information. That kind of data you can use to extract the DEM with the help of this DEM extraction module on the ENVI software. So on this DEM extraction module you will see the DEM extraction wizard, and once you will click on this DEM extraction wizard, so you have to choose the new file from the DEM extraction wizard, and once you will choose the new file, you will see that such type of window will open. Here you can see some options are given. For example, you have first option is stereo pair image, and on this stereo pair image you have to first select the stereo pair image. So you are having the left stereo pair image, and another is your right stereo pair image. That means your band A and band F. So you have to select accordingly left or right stereo pair image with the help of this option. And once you selected your stereo pair image, you would see the minimum and maximum elevation over here, which is, you can see the scene elevation in meter on your DEM extraction wizard. So once you click on the select stereo pair image, you would see that a new window will open, and from here you can see the select input band and band information. So all the band which you are selecting, that you can see over here, and the information regarding the band, the latitude, longitude, or the elevation, or the acquiring information of the related to that particular band, you will see all this information over here. So from the open menu you can choose your new file, and once you choose your new file, it will direct you to your directory where your band is saved. So you have to open both the forward and afterward band accordingly, and once you open all your both the band, you can see both the band in the select input band option, and once you click on any of respective band, and all the information regarding this band you will see on the right side in the band information option. In the band information option, here you can see the dimension of this band, or the size of the file, the format, or the sensor type, or the projection, and the other information which is given to this respective band. Accordingly, you will also see the information which is related to band A also. And once you open both this band, now you have to choose the RPC information, or that is the rational polynomial coefficient. So this rational polynomial coefficient you would need you would need to do the triangulation or orthorectification method. So to do the orthorectification, you have to choose the rational polynomial coefficient for both this band. So first you have to select the rational polynomial coefficient or RPC value for band F, and then you have to choose for the band A. So first few things here you have to keep in mind. If you are opening band F first, then you have to choose the RPC value for band F first, and then you have to choose the RPC values for band A. And if you are opening your band A first during the selecting band, or then you have opened your band F, so accordingly you have to choose your RPC values for band A and band F. So here you can see, once you will select your band A, so you have to first choose the RPC value for band A. So you can see in your raw data you will be having some information that would be your band A TIFF format, band A metadata in text format, band A RPC in text format, and band A RPC underscore org dot text format. So this band A RPC org dot text format, in this file you have all the information regarding the band A. So you have to open this file for the orthorectification. So first you have to select this file and you have to open, and accordingly you have to select the RPC values for band F also. So you have to open both RPC file both this band, and once you have selected for the RPC for both this file, now you will see here the minimum and maximum elevation for your data. So for this respective data, you can see the minimum elevation for this area is 400 meter and the maximum elevation is 5100 meter. So once you can see the elevation data over here, now you have to click on the next option, and a new window will open. Here you have to choose certain kind of information. You have to assign the this GCP value. For example, this GCP is the ground control point. So the image which you have selected to generate the DEM, if you have the ground control point, that is the true latitude or longitude of this region, so that you can choose from your file. And if you don't have the GCP's values, in that case you just select the no GCP or relative DEM value only. So this GCP value, if you are adding in your DEM, so that will enhance the resolution or the sharpness of the DEM. So if you are having the GCPs, then it is okay. If not, then you can choose the no GCP value and you click the next option. So once you click on the next option, now you have to give certain more information. So that would be your tie points. So tie points are basically the common point in both the images, so that you have to select, because in this image orthorectification you have to just overlap the two images over each other to generate the DEM or Anaglyph. So in this process, how you will do this? You have to do this with the tie points. So tie point would be some common point or features in both the images which you can easily identify. And when you identify this tie point on both the images, so with the help of this tie point, this both image will overlap to each other. So you have to select the tie point. So to generate the tie point, here three options are available. First is generate tie point automatically. So with this option you can generate the number of tie point automatically. The system will generate the tie point, and then you have to manually rectify those tie points and to generate the DEM. So here to generate the tie point automatically, here certain options are given: the number of tie points, search window size, window moving size, or regional elevation. So this information you have to provide to generate the tie point automatically. The another second option is define tie point manually or interactively. So with this option you have to choose the tie point manually, and the number of tie point you want to choose, that you would do with the help of the window which will open up in the next slide. So with this window you will choose the some common position or the points in both the images, so that you have to do the manually. So with this option, define tie point interactively, you can do this. If suppose you have previously done this exercise and you have some kind of tie point you previously saved, so that file you can use from this third option, that is read tie point from the file. So with this read tie point from the file, you can upload your tie point directly from your file, and that you can use to generate the DM. So once you have assigned or you have chosen your criteria, so then you have to click next. For example, in this exercise we have chosen the generate tie point automatically option, and here you can see we have assigned the system to generate 25 tie point with the search window 81 and moving a window size 11, and the regional elevation is 2750. So the system or the software will automatically choose some common point, and that will give you to the 25 tie points, but this tie point will associate the error, so that you have to manually rectify. So once you have done this, you just click on the next. Now you will see that automatic tie point generation window is open, and once it done 100%, so you will see a few windows will open. Here you can see both your band A, that is your afterward image, and band F, that is your forward image. So here in this scroll 1, you would see your forward image. So this is your entire image, here you can see, and this scroll 2, here you would see your afterward image. And for a particular reason, suppose this is here in this screen, here you can see it is 1. So the tie point which is number 1, for example this area, so this area you can see over here. So this is the band 1 and band 2, this window are basically the zoomed portion of this area. So the where we have marked the, or the system has automatically assigned the tie point number 1. So this is your zoom up portion of this area. And the another window you can see, that is in pixelated form in zoom 1 and zoom 2. So these two windows are basically the further zoom up portion, or in the pixelated form of the area where we have assigned, or in this case the system has marked 1. So this region is you can see over in this zoomed window in the pixelated form. So this pixelated window you can manually zoom in or zoom out to get a pixelated representation to more accurately mark the tie point. So you can do this with the help of this plus or minus sign. So once you have understood all the basic idea of all these windows, then you have to assign your tie point in case you are marking the tie point with the manual option. But in this case we have chosen the automatic option. So here you can see system has automatically assigned 25 tie points. So you can see this 25 tie point is manually automatically distributed over any point. For this for example, the tie point number 1, you can see the location where this point 1 has been marked, this is not the same place which is marked in band A or band F. So these two locations are different, or the two object is different. In this case what will happen, your parallax would be higher. So here you can see this is your maximum Y parallax. So this is for this case it is 89. So to generate the DM or the Anaglyph, this parallel should be minimum. So generally we are trying to keep this parallel below 1. So the high parallax value will give you more accurate DEM or more accurate Anaglyph. So here with this DEM extraction wizard, you can see some more options are given. So with this option you can manually adjust the tie point which is associated with the error. So here you can see first the left right stereo pair coordinate. Here you can see the left x and left y. This is basically your longitude and latitude for this respective image or the point where one has been marked, because presently this window we are seeing over our software. So for this window for this point 1 you can see the latitude and longitude. And in the second option, view and edit tie point, with this panel you can edit your tie point. For example, I want to just correct the location for my tie point. So first you have to delete this point and you have to choose a common location. For example, in this image you have to first see that which two area or which object you can clearly identify in both the image, in band F and band A, and you select one similar object. That could be your house or that could be your road crosscut. It is similar which we have explained in one of our lab. So how to mark the tie point. Similarly, you have to choose the your location or your object where you want to add your tie point. So once you have identified, so you just click the area first in the scroll 1 image, in this image, and then same area you have to choose on the same scroll 2 image. For this case we have already chosen the, here we can see this area in this zoomed portion, but here you cannot identify because this two area is different. So to select a common area you have to first click on the scroll 1 and then scroll 2 and then if you are identifying the same area on both the image in the band A and band F, then only you select a common point or common object with the help of this band A and band F. And once you did that, so you have to go to the pixelated window. On this pixelated window you have to select the same location and the pixel level. So for that you can zoom these pixel values, because if you are, what will happen to if you are zooming this pixel value, so that will, because now you can see this pixel window is showing for this much area, and if you are zooming this pixelated window, so this area will be minimized. Suppose I am keeping this zoom portion to 60x for example. So on this 60x this will show you a single dot in both the images. So that would be giving you a higher accurate tie point, and your parallax would be minimum in this case. And suppose I am keeping it in 1x, so in this condition you can see this pixel value could be anywhere on this box for the both band A and band F. So that will give you a more error in your Y parallax. So parallax is basically your shifting. What is happening whenever you are seeing a single object or anything with the two different angle, so there would be a slight shifting or displacement in your object when you are seeing your due to your angle variation. So that is giving you a parallax. You can do a simple exercise. Suppose if you want to see your this finger with the help of this two eye, so you can consider this two eye as your as a camera, and suppose if you are closing one eyes, you would see that you can feel that your finger is shifting. So this shifting is basically called the parallax. So that is also happening in case of satellite data acquisition. So during the satellite data acquisition there is two kind of shifting. One is parallax X and another is parallax Y. So in parallax X, so suppose this is your flight direction and your data is acquiring suppose this is your all the scenes are acquiring. Okay, so if you are shifting in the object is in the parallel to the flight direction, so that will be your x parallax. So that is your x parallax. And if your shifting is orthogonal or the right angle to the flight direction, so that is your y parallax. So this is your x and y parallax. So this parallax is basically associated with the displacement or shifting of your object. So to generate the DEM or the high resolution DEM or the Anaglyph, you have to keep this parallax below 1. So that you can do by editing your tie points. So once you have done this all this exercise, or you have marked all your points accurately, then you can go to the next option, and here you will see that here you can see. So here you can see we have marked 125 point, and now the parallax is 0.75. So with this 0.75 you can generate a high resolution DEM or Anaglyph. So here you can see, so in the earlier slide this was the two different object which the system has automatically selected. Now we have corrected the point, and here you can see this 2 point, the point 1 on the band F and band A is on the same location. So this will give you a minimum y parallax. So now you can see the y parallax is 0.75. Earlier it was the around 90. So once you have marked your number of tie point, or you have corrected the y parallax, now you would be able to generate the Anaglyph or the DEM. So you have to just go to the next option. So here some more options are available. You can explore this option while doing the this exercise. So here you can see the show table. So with this show table option, you would be seeing all the tie points which you have marked, or the error associated with those tie points. So you would see over here, and you can save this tie point with this save option. So if you are saving this tie point, you can use in your means in future exercise to generate the Anaglyph. Suppose if you have marked 165 tie point in first time, and then you want to add more tie point in coming days. So in that case you have to first save those tie points. So to save those tie point, you can simply use this option. And to restore tie point, so you can restore your tie point from this option. So this likely error ranking, this will open a table, and you can see that which tie point is giving you the more error. So you can identify the highest ranking of the tie point in terms of error, and you can delete those tie point accordingly, and you can choose the new location or new object, or mark a new tie point delete the tie point which is having the more error. So after doing all this exercise, you just click on the next option, and once you have click on the next option, now the new window will open. Here you can see two options, one is left epipolar image and another is right epipolar image. So what is happening? So epipolar means, so this Cartosat-1 data is the panchromatic data which is acquiring information in the visible range. So that is having 3 band. First is red, and then RGB, that is red, blue and green. So this RGB is basically assigned separated into 2 color. So first is your cyan color and another is your red color. So this cyan and red color is giving you a 3D perspective. So this left epipolar image, that means your blue and green color is assigning to a cyan color and your red color is separately assigning another band. So that process is called and the generation of a new image is called the epipolar image. So you have to choose the output for your epipolar image, and you can set your directory and for this left epipolar image and right epipolar image. And here you can also see the epipolar parameter. So that is the reduction factor. So reduction factor means you can increase or decrease your pixel size. So that you can do by this reduction factor. So this one means your pixel size is 2.5 meter, and if you want to increase or decrease, you have to change this reduction factor value. And another option is your examine epipolar result, that is RGB and RGB left right right and right left left. So as I already told you that this epipolar image means your blue and green is assigning to a single band, that is your cyan color, and your red color is assigning to another band, that is your red band. So with the help of this left epipolar or right epipolar, you would be able to generate your Anaglyph, that would be your 3D perspective view. So that you can choose from here. So this will change accordingly how you have chosen your band A or band F. So that accordingly you have to choose the your left right right or right left left. For example, if doing the Anaglyph generation, you have chosen first your forward band, that is your band F, so that is your right, and after that you have chosen your band A, that is your left band. So you have to choose this option, right left left option. So that will give you a positive perspective view of your Anaglyph. And if you are choosing the left right right option, so this will give you a negative perspective view of Anaglyph. So to choose the left right right option, you have to first choose the first band A, that is your left, and then you have to choose the band F, that is your right. So for that condition you can choose left right right. So once you have chosen your output directory for left epipolar and right epipolar image, you just simply click on the next. So a new window will open. Here you have to assign or you can see some basic information regarding your DEM. So here you would see the projection system, that is your WGS84 or UTM43. And here you can see the latitude longitude information, and here you would see the pixel information. So these are some default value, you don't need to change anything from here. You simply click on the next option, and here a new window will open. Here you can see some basic information regarding the DEM extraction parameters. So here you can see the minimum correlation, background value, edge trimming, window size, terrain relief and terrain detail. So on the terrain relief, if you want to get the highest resolution from your DEM, you can change this moderate to high option, or if you want to get a low resolution DEM, you can keep it to the low or moderate. And you can also shuffle this terrain detail, that would be from level 4 or level 1 to level 8. If you want to get the moderate DEM, then you can keep it to the moderate in the middle, that would be 4, or if you get the highest high resolution DEM, you can keep it to the 7 or 8, or if you want to get the low resolution DEM, you can keep it to 1. And from the DEM result, you can see the output data type is integer and another is your floating point. So you can choose so this integer will give you the low resolution DEM, and your floating point option can get the high resolution DEM. So you can, based on your interest, you can choose this option, or you can shuffle these options. And once you have chosen your option, you can just give the directory for your output DEM and you click on the next option. So once you click your next option, you can see some processing. The software will do some kind of processing. So first option is your creating left epipolar image. So you can see that the directory which you have assigned for your left epipolar image, so this left epipolar image will generate, that would be your blue and green color is assigning to a single band, that would be your cyan color. So that image will generate and the image will be saving in your directory, and another window will open once this has been done, and then another window will open that will create your right epipolar image, and similarly this right epipolar image will generate and that would be your single band of red color. So this will vary according to what you have chosen during your band selection. So if you are choosing your band F first, on that case your right epipolar image would be your red color and your left epipolar image would be your cyan color. If you are selecting the band A first, then your right epipolar image would be your cyan color or left epipolar image would be your red color. So this will vary according to the based on the selection of your band during the initial steps. So another window will open that will build your parallax. So the tie point which you have marked for both the band A and band F, so those tie point will be, with the help of this tie point your both the band A and F will overlap to each other, and that overlapping will be done through the parallax building. So with the help of those tie point, the parallax image will be generated, and then another window will pop up and that will be generate your DEM. So here you can see all the some methods on which method the system is processing your sample or your map. So here for example the DEM generation has been done by the triangulation method, or this epipolar generation is been doing by the bilinear resampling method. So all this bilinear or the nearest neighbor I already explained you in previous lecture. So once all this processing has been done, so you would see two window will open. First the DEM extraction wizard option, or the another is the band window. So here you would see all the band which has been opened on the software, and on the DEM wizard you would see two option. One is load DEM result to display, another is load DEM result to display with editing tool. So you can simply click on the load DEM result to display, and this will display you the DEM. So here you can see your DEM has been generated, and this DEM is a high resolution DEM with a spatial resolution of 2.5 meter. So you can save this DEM with the right click on this scroll window. So once you are right clicking on with the help of your mouse on this scroll one window, so you will see a new pop-up window will open. Here few options are given, and with the help of save images you can save your image in the TIFF format. So you can see here you have to choose the resolution, that would be a 64-bit format image, and you can select this with the help of this drop down menu, and you can select the VSQ or VIL format. Any of this format would be good for the generation of high resolution DEM. So you can choose this option, and you have to simply choose the TIFF GeoTIFF format from this drop down menu, and you can assign the output directory, and you can save your DEM. So with this window you would be able to save your DEM, or this DEM would be the high resolution DEM with a spatial resolution of 2.5 meter in case of Cartosat-1 data. So another window was your this available band list. So with this help of this band list you can simply load the band, and you can generate the Anaglyph, that is your 3D representation of the surface, and that you can see on a 2D monitor with the help of 3D glasses. So as I already mentioned that this Anaglyph would be consisting with the red and cyan color, so you would be needing the red and cyan color 3D glasses to get the information from the Anaglyph. So we will see that how we can see the Anaglyph with the help of this different bands. So here you would see that what type of information you have input in your ENVI platform, and what you have got from this processing. So you have added the band F and band A information, and you have got the band F left epipolar image, band A right epipolar image, and DEM. So this DEM we have shown you that how you can save or you can see your band. So now we will see that how we can generate the or see Anaglyph. So to generate the Anaglyph, first you have to choose the RGB value, because this is the red and cyan color or the RGB values. So you have to choose the RGB color, and once you are clicking the RGB value, you would see three options. One is R, red, green, and blue. So to generate a positive structure view, so you have chosen band F first and then band A during the band selection. So you have to choose the right epipolar image in the red option, and then left epipolar image for the green or blue. So with this selection, you would be able to get a positive view of your Anaglyph. And suppose if you are selecting the left epipolar image on the right band, so and right epipolar image on the green or blue band, so you would be seeing the negative structure of the Anaglyph. So to select the image, you have to simply double click on the on this option, right epipolar image. So you have to keep the cursor on the red, and then you have to double click on the right epipolar image, and you would be able to select the different band. And once you have selected all the bands, and simply you click the load RGB value, and that will be enable the few windows will open, and here you can see this is your Anaglyph. So this is a 3D representation of your data, and with the help of 3D glasses with the red and cyan color, so you would be able to get the information or geomorphological or tectono-geomorphological information from this Anaglyph. So here you can see this is your this scroll 1 is having the entire image or entire data, and this window is having a information for this particular area only, because this we have selected this region. So this on this window you would be able to see the information only for this specific region, and on this zoom window you would be only seeing the information for this rectangle area. So this information you will see on the zoom window. To save this Anaglyph, you simply go to the scroll 1 and right click over this image, and you would be able to save as your image as a TIFF format. So you save your image in TIFF format, and that you can see or analyze in any GIS software or image viewer software. So with this help of this Anaglyph, to extract the information from this Anaglyph, you would need the 3D glasses. So 3D glasses which is having the red color. So this is your red color glass, and another is your cyan color. So this red and cyan color would be needing to extract the information from the Anaglyph. So this will filter the red and cyan color from the from your image, and you would be able to see the image or the geomorphic feature in 3 dimensions. So you can imagine that with the help of this 3D images or the with a spatial resolution of 2.5 meter, you would be able to get the all kind of information. So for example, you can get the scarp detail, or you can get the terraces with a spatial resolution of 2.5 meter. So that kind of information you would be used during the mapping part. So you have to first identify all the tectono-geomorphic features from your data, and then you would trace all this information with the help of GIS software, and you can prepare the a tectono-geomorphic map. So this is a example of tectono-geomorphic map. So here this map has been prepared with the help of the Cartosat-1 Anaglyph. So here you can see we have mapped the terraces, different level of terraces, and the alluvial fan surfaces, geology of the region, fault scarp, and the different geomorphology. So these all information has been traced from the Anaglyph on the QGIS, that is a GIS platform. So when you open your Anaglyph on the GIS platform, you identify your geomorphic features and you trace your geomorphic feature and prepare a such kind of map. So this will give you a detailed mapping of your area. So in next lecture we will teach you, or we will explain you, that how we can use this data on the GIS platform, that would be on the QGIS, and how we can prepare such type of tectonogeomorphic map with the help of Cartosat-1 data on the GIS platform. So thank you.